Alright, good morning guys. So this is actually your Thursday video, but today in real life is Wednesday, so I am wearing my pink shirt per my Mean Girls rule. So yeah, if you're watching this video, in theory you guys just took your first quiz yesterday. Be looking ahead that there is a test next week, so if there are things in that quiz that you did not understand, definitely make a plan to come on to one of the Zoom calls and ask for some help. I will say quickly that today is your first no homework night, and I'd probably put this in your check-in already, so you're like, I already heard this. But basically, today's just going to be sort of the notes on what to do, and then you won't really have anything to turn in. So just watch this video and call it a day. And then tomorrow there will not be a video. You'll just work on the practice page for that. And I'll send that out in a reminder again, but because that will be a Friday assigned homework, you do have until Sunday at midnight to get that in. But again, I'm going to encourage you to get that done like ASAP, because you're going to forget, you're going to get involved in a lot of other things, and I don't want you panicking on Sunday at midnight trying to turn in a homework right. Okay, so what we're doing here in section 9.4 is what we refer to as a composition of transformations. And all that means is that you're doing multiple transformations in the same problem. A lot of times we will only do like 2 or at most 3, just for the simple fact that the more you start flipping stuff all over the place, it starts to get really sloppy and disorganized. Some students generally, when I find take a quiz or a test or a homework just for their own organization, they'll either bust out highlighters, colored pencils, something. That way they can sort of distinguish like the original figure, the first step, the second step, the third step if there is one, etc. So just kind of keep that in mind. On the smartboard, I am going to use different colors. It might be recommended to do that as well. Also, friendly reminder that with our notations, like let's say for this problem, I randomly called these 3 points A, B, and C in just whatever order. Normally they would already be labeled, or the question would tell me. That I'll need to, as I do transformations, add those little prime tick marks to the problem. So in a series of transformations called a composition, you have to do them in order. There are very rare exceptions where it would end up being the same, but that would not be something to learn. Like, you just need to do them in order, because anytime they end up the same is more of a coincidence than anything else. So this is telling me to do a translation of the point, right 6 and down 5. And then after I am done with that, don't try to do it all at once, you're then going to reflect over the line y equals 0, and I'll talk about that in just a second. So right 6 down 5, to me, I'm just going to grab these points and count them. If I knew the ordered pairs, yes, maybe I would just add 6 and subtract 5, and that would be quicker. But here I'm going to go 1, 2, 3, 4, 5, 6, down 1, 2, 3, 4, 5. That is my new A prime. B is right 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, down 1, 2, 3, 4, 5. So that is sort of transformation number 1, not the final answer. Some questions might ask you to go ahead and label the ABC points, and then it will ask you to label the prime points, and then it will ask you to label the double prime points. In that situation, yes, fill all that in. But generally speaking, we're going to just be looking for the final image after that pre-image has done its composition of transformations. So now we're reflecting over the line y equals 0. So again, you got to remember the difference in a y equals a number graph is going to be horizontal, and x equals number graph is going to be vertical. When I teach Algebra 1, we kind of joke about that vertical lines, that up down is what's considered the undefined slope, and then it ends up being the x equals graph. And so we kind of organize vertical lines or undefined slope as an x graph. And why we kind of do this is sort of like a funny thing. It sounds like a bad word. We would say, what the bucks? And you're like, whoa, what did you just say? I'm like, I know, I said bucks with a V. But the only reason I'm pointing it out is it is kind of a silly way to help remember that the vertical is the X line. So what the bucks? X is vertical. So in this case, a y equals graph is not that, it is horizontal at y value 0. So when I go to y value 0 and draw a horizontal line to reflect across, for this question that happens to be the x-axis, but they chose to represent that as an equation as opposed to a vocabulary word. So just kind of keep that in mind, keep your horizontal and vertical in your head correctly. And let's go ahead and reflect. So this A prime point is on the line of reflection, so there's nowhere to count, right? So like B is like above it 1, 2, 3, so you go below it 1, 2, 3 and label that B double prime. But A is on the line, like it's 0 spaces away, so it stays where it's at, and I could go ahead and continue to label that as A double prime. Anyway, C is 1 point above, so then 1 point below. Here is my final image. If the question asked where these were, then yes, I would read off all 3 of those ordered pairs and label them. Okay, so that's just generally how a composition works. Main thing is you must go in order, and this is what proper labeling should look like if we are asking for that. Let's do a couple other ones, just dealing with some like weirder things that might happen. This time it says rotate the segment. So instead of rotating the triangle, when it says rotate the segment, we actually do want to see the 2 points and have them connected. So that might seem nitpicky, but this shape is called a segment, so we want it to continue to look like a segment. The 2 things that we're doing here, we're going to rotate it 90 degrees. It doesn't say positive, well, it is positive, and because it doesn't say the vocabulary, we know that that is a counterclockwise turn. And then after that, we're going to reflect it over the line y equals x. And y equals x, again, is like start at 0, slope of 1 over 1. So that means reflecting over that perfect diagonal line. So I want to kind of retouch on those things. So if we're reflecting around the origin, I know that that's my rotating. This A value is to the right 1, up 1, 2, 3, 4, 5, 6, 7, 90 degrees this way, click, right 1, up 1, 2, 3, 4, 5, 6, 7. Okay, that is A, so that's my A prime. B looks like it's at 1, 2, 3, 4, 5, 6, 7, 8, up 1, 2, 3, 4, so right 8, up 4, turn my head, 1, 2, 3, 4, 5, 6, 7, 8, up 1, 2, 3, 4. B prime, and because it's a segment, I am going to go ahead and connect those because that is the shape that we're looking for. So we rotated this point 90 degrees. Reflecting across y equals x. So I'm going to kind of just carefully plot those 1 over 1 points to give me where this reflection line is at. If you want to use the rule, you can, like find where that ordered pair is and use the rule for that. But the way you reflect over y equals x again is you just take a point, let's say point A. Your choice, either count how far over sideways it is and then count that distance up down, or count the distance the up down and then count that distance horizontally. Both of those will end up at the same point. So for example, this is 1, 2, 3, 4, 5, 6, 7, 8, and then go straight up down 1, 2, 3, 4, 5, 6, 7, 8. And I know to go down because I'm reflecting across this line. If I had gone up, I would have been on the same side, right? So that's kind of also where my thinking is. That is my A double prime. B, I'm just going to go sideways, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Connect those as a segment, and then again, if they ask me to label those points, I can now do that. All right, let's look at maybe whatever this one's saying. So it says reflect the check over the line x equals -4, and then reflect it over the line x equals 3. So again, x equals graphs are what the books. So they are what the books, which means that this x graph is a vertical line at -4. So 1, 2, 3, 4, up and down. So this is the line that we're going to reflect across. Yeah, I'm just going to sort of highlight the main points on this guy and then count those over. So this upper point is 2 spaces away, so 2 spaces. This middle point is 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And then this lower point is 1, 2, 3, 4. So 1, 2, 3, 4. And then I'll connect them. And you'll notice that this is like that fold line that if I were to fold this paper in half, perfectly matches up. Now they want me to reflect over another vertical line of x equals 3. So we're going to +3 and drawing that vertical transformation. So here we go. Highest point is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 1, 2. 1, 2, 3, 1, 2, 3. Okay, and at the end you might notice that it kind of looks like they could have just slid this over, right? There would have been an easier way to get there, but that just happens to be the result of doing those two reflections. Okay, one last problem, and this is more like what your homework is going to look like tomorrow. You're going to get a page of a bunch of these where it gives you two transformations to do, and it is going to ask you to fill out the in-between step and the final location of your image. So I just want to work through one that looks like this. It does say a triangle, PQR, so I am going to label these points and keep up with them. So P is 2, 6, Q is 4, -2, and R is -3, -3. And because it says triangle, we are going to expect that you connect them into a triangle and don't just have the 3 points there. Again, it seems nitpicky, but we are in an advanced geometry course where the little details are going to matter later. So that is going to be requested of you. It's not asking me to label that because it's kind of given in the problem. So now I would probably switch to a colored pencil or a different thing and look at the first transformation. This transformation says, hey, just add 4 to the x's and do nothing to the y's. Now, I'll be honest, this type of a transformation, it might be easy just to apply the rule and write them down. Like, I don't have an issue with that. Sometimes there's a place for that, especially when I can see the numbers like staring at me in the face. So P, if I'm just gonna add 4 to the x, like 2 plus 4, 6, and then the y didn't change. For Q, 4 plus 4, 8, and then the y didn't change. And then R, -3 plus 4 is +1, and then the y didn't change. And now I can just go plot these points. They should end up in the same place as if I just grabbed this point, walked it 1, 2, 3, 4 to the right, and then did nothing. Okay, 1, 2, 3, 4 to the right, 1, 2, 3, 4 to the right. So you could sit here and argue what's easier or what's faster for you, because somebody's like, I could just slide these over 4 real quick, and I don't have to think about adding. Other people are like, well, I can just add them real quick and then replot them. It doesn't matter. It's up to you, whatever makes sense. This is a case where the rule is fine. The next and final transformation is a reflection over mx. Remember that the m is the notation they use for reflections, whereas like t is for translations. And if it just says x, that's not like an x equals line, that means the x-axis. So whereas like an x equals graph is vertical, this x-axis is this horizontal axis. So sometimes when you're first getting that going in your head, that is a common confusion of the x equals line versus the x-axis. So just kind of, yeah, already said that 19 times. So let's just reflect those points. So let's say P is 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. That's P double prime. Q is down 2, so then up 2 more. And lastly, R is 1, 2, 3 spaces, so 1, 2, 3 spaces. And when I connect those, you get that. And so this here again is for a couple of things. Number one, why I suggest using different colors or highlighters to just distinguish these things. And you notice it's already starting to get sloppy just doing the original image, well, the original pre-image, and then the 2 subsequent images. That we often don't like to do much more than that because it does start to get real messy really quickly. But that's it. Like I said, this video is to watch it. The homework will populate tomorrow and you will just basically be practicing this. So have a good day, have a great weekend. If you do have questions, of course, you're welcome to pop on the call. If you didn't come on the call today, you can come on the call tomorrow, Friday. If obviously you wouldn't have done this homework, but maybe a previous homework you still had questions on, or there's things from the quiz maybe you were curious about. Just any general questions you might have, that is going to be open up for you. So yeah, have a good one.